So, hey folks, we today are here going to present you our new development in Rancher and CAPI integration world, which is called Turtles extension. We're going to present together with Furkat and me, Daniil. We both work on the team. Yeah, and I hope you'll like it. We're going to show the deep dive demo as well, and probably go in some details about cluster API for cases that you are not familiar with this concept and this project, which is Upstream 1. So, Furkat?
Yep. Hey folks, I'm Furkat. I work with Daniil. Yeah, with that, let's get started.
Yep. So, agenda. We're going to talk about what is cluster API, some brief functionality overview. Cluster API is quite complicated topic, so we're not going to go into deep details, but we're going to show some of the important concepts we utilize and probably you'll see on the demo. Also, we're going to talk about Turtles and how they act as a integration point between Rancher and Cluster API in a native to upstream manner. Yeah, and demo as well, which is going to be hopefully interesting and a live one, but in case it doesn't go well, we have a recording for this as well. Yeah, and some statuses, roadmaps, contributions, questions after that. So, hope it's good. Let's get started. Cluster API. So, your turn?
Yep. So before going to Cluster API, may I ask how many of you have heard about Cluster API or used Cluster API?
It's good.
So most of the people know what is Cluster API, right? So I'll just give a brief introduction and what is Cluster API. So Cluster API is upstream open source project under the Kubernetes SIG lifecycle, and it focuses on cluster lifecycle management. The initial idea or motivation behind was making the cluster lifecycle boring. It focuses on creation, management, and configuration of Kubernetes clusters using Kubernetes-style declarative APIs and patterns. So what that means under the hood is CAPI running on Kubernetes, using Kubernetes, and creating other Kubernetes clusters.
Yes, so it's not like you have something which creates a cluster. It's a Kubernetes managing Kubernetes. Anything could be like a kind cluster. You can start on your local machine and you can deploy anything in any cloud environment. CAPI is essentially a set of contracts the provider satisfies with, and you can deploy clusters on any cloud environment, on-prem environment, any sort of supported situations. So that's the main goal behind having this integrated into Rancher, because we bring lots of upstream contributions, lots of support, and folks who are deeply invested in those topics as well.
Right, yeah, so CAPI comes with some building blocks, as you see, like cluster templating, managing the lifecycle of cluster, like normal operations, creation, update, delete, automation of scaling, repair and upgrades. It has the capability of distributing the nodes across failure domains, and also machine health checks where they can replace the unhealthy nodes in your cluster. And lastly, the managed control planes, where you have the control planes managed by services. And yeah, you might ask why we should care. And yeah, there are lots of provisioning tools, but CAPI has lots of benefits that we see, and one of them, or one of the key principles that we see, is its extensibility. So it has capability of provisioning your target infrastructure in number of cloud providers or environments, and to do so, they have a concept called providers. As of today, I could count 30 plus infrastructure providers for CAPI, and the list is ever growing.
Yeah, and mainly as you will see how the provider can be installed in the cluster and what it brings. So we're gonna jump to diagrams of how CAPI works. And the main thing to understand here is that nothing comes in CAPI embedded. You can bring your own provider. You can write your own provider. So yeah.
Yeah, so let's take a look briefly at how Cluster API works. Basically, in this diagram you see the CAPI in a nutshell. In CAPI there's a concept called management cluster. And what it does is basically it's responsible for creating and managing fleet of workload clusters where you have the Kubernetes workloads running. And the management cluster could be any local kind cluster, or it could be cluster created in managed services, or it could
can be Rancher.
Rancher or Kubernetes CAPI itself created cluster.
As you can see from this diagram, there are also some components. Essentially, it's a set of custom resources. The cluster is the most important one, but you can see the correlation on the diagram with the, I guess, color, which components belong where. So, and there are some example distributions or some example providers, implementers like AWS, GCP, Azure. Folks there are working on this, so it's respectable. Yeah, let's go to the next slide.
I'll just quickly go through the providers. So providers, there are 4 main type of providers in CAPI: core, infrastructure, bootstrap, and control plane. The core, it's a provider responsible for managing core CAPI controllers. Infrastructure provider is responsible for provisioning and creating your infrastructure resources in your target environment. Bootstrap provider responsible for generating the cloud you need and turning your machine into the Kubernetes node.
Yeah.
And the control plane provider is basically for managing the control planes.
You can understand that there's a separation between control planes and workers in CAPI world, because for one example, it comes handy with those managed environments where AKS or GKE typically doesn't provide you with control planes in your clusters. You only use worker nodes, so it's basically targeted for the customers who want to have their applications deployed in those clusters and don't want to worry about managing control planes. And they also have some specific differences in terms of scalability, because you have etcd cluster running behind, which should be a quorum of nodes and things like that. So those are different provider types. Yeah, another one?
Yeah, so if you go deeper into the infrastructure provider, so for example, if you are creating the infrastructure provider, then you will be creating basically the custom resource to represent the infrastructure where you will be creating your target environment. So on top you see the cluster CRD. It's pretty much the root of all other CRDs in CAPI, and it defines basically the spec, which is the environment agnostic first of all, and is responsible basically for managing your cluster lifecycle. And infrastructure cluster, so it's one-to-one mapped with cluster CRD, and it represents basically the base infrastructure where that's required for the cluster, and it's for like things like networking, security groups, or and down there are like machine and infrastructure machine CRDs. Machine is representation of Kubernetes node, and then infrastructure machine, it will be basically contain the specific configuration to create the actual machines.
Yeah.
It could be virtual or physical hosts,
containers,
or or like EC2 or GCP. instances.
Depends on the provider you're using. It can be bare metal, so you expect some actual servers running behind, but it could be anything, virtual machines, whatever cloud is using, you're going to use. And one of the interesting components is machine health checks, which allows you to declaratively control the health of your machines in case of either of those components doesn't respond. The CAPI will manage recreation from the template of your infrastructure components if something goes wrong, depending on the rules declared there. So there are some interesting things, I believe.
Yeah, machine pools maybe. Yeah, it provides, like some infrastructure providers, they support the machine pool machines where they have infrastructure machine pools, basically, that you see on the slide. And they will be basically responsible for creating infrastructure machines in that pool.
Yep.
And whenever you scale up, let's say, a machine pool, it creates the machines and infrastructure machines accordingly.
Yeah. Let's jump to the next slide. We're going to talk about providers. And one thing which is called CAPI provider. It slowly diverges to the integration in Rancher, because we have our own thing. Essentially, CAPI provider is a set of controllers operator managing those custom resources to provision in your target environment infrastructure components declaratively. So let's say a provider could be a Docker provider. You create a Docker cluster and you want a Docker machine running inside a container. You just install this provider, and then the cluster accepts declarative definitions for Docker machines, Docker templates, and things like that. As well, it could be AWS, GCP, AKS, everything supported upstream. Additionally, in Rancher, we have RKE2, Bootstrap provider and control plane provider we're using, which is also a provider in the CAPI world. Satisfies set of contracts and basically provisions your cluster using this product. Yeah. Let's talk about provider types. There are several of them. Main component of this is a core provider, obviously, is the CAPI itself. Without this, the cluster doesn't know what is the cluster, what is machine, what the machine deployment is. Once you install this as a declarative resource, you can install some infrastructure, Bootstrap, and control plane providers. These are required set of dependencies. One of them, infrastructure provider, again, Docker, as I mentioned. Yeah, you can do some things like configure networking with that, security groups, something specific to the environment you're gonna run your cluster in. Bootstrap, which is as well equally important component. For example, in upstream there's kubadm, Bootstrap provider. They typically use, for us it's RKE2. But you can also bring your kubadm provider and install in our Rancher cluster if you want to try this out. It works. So it's responsible for preparing the Kubernetes components, starting the nodes, kubelet, etcd, API server, KCM, things like that. So they all work in tandem and form a freshly created cluster for you. Also, you can declare some overrides, some files within it. And yeah, there are not many of them, but Bootstrap providers are very important to start your cluster, regardless of the environment. And the control plane, which is essentially a set of operators, controllers managing your control plane definitions, which can follow some different scaling requirements. You shouldn't break the quorum for etcd, for example. They should be entirely decoupled from the worker machines, because, well, in some scenarios you might say CAPI supports bring your own host scenario, so we can essentially run several workers in different cloud environments, but it's not like a mainstream approach. But still, with those pluggable implementations, you can do this. And some other ones, which are nevertheless important, add-on, EPAM, and runtime extension. Those are experimental so far in upstream, but you can bring some things like I'm going to show this add-on provider for Fleet, which will integrate Fleet within the Rancher cluster with cluster API, allowing you to automatically provision applications inside the cluster once the cluster is bootstrapped. which can be useful. Runtime extensions, those probably come in some more deeper level CAPI use cases where it uses cluster classes. So you can inject some variable definitions, patches for your template before provisioning the cluster. I think it needs a bit of an explanation. Forgot. Do you have anything to say? I can go to the next slide. Yeah. Yeah. So as you can see, there's a set of CRDs where we have a cluster which corresponds one-to-one to a Docker cluster. There is definition. As you can see, there's a reference to Docker cluster. That's how you declare in which environment or which provider you want to use in this scenario. And also there's a machine which was created by CAPI, where it references the kubeadm configuration, which is a part of a kubeadm bootstrap provisioner, and declares how you want to provision your kubelet, controller manager, or do some additional commands which you can see here. But still, as you can see, it can be anything. So essentially, if you bring or write your own provider for this specific environment, you should be good. That's what all folks in upstream did. And the Docker machine, which declares specific for the, I guess, container type of node dependencies it has to bring. So machine references these things. Cluster classes. We're gonna go to them later. But let's talk about cluster API and Rancher integration.
Yeah. So introducing the Rancher cluster API extension. So as Daniel mentioned, we built Rancher turtles. This is how it's called because CAPI is turtles. So that's what we followed. It's
turtles all the way down.
All the way down. It's an extension to Rancher that brings full cluster API integration to Rancher. This is a logo, and we have QR code generated. If you want to take a look at
our documentation,
where we have full set of documentation and it's improving. About the goals, so we designed the turtles to work with any combination of providers possible, which is supported by CAPI by contract. One of the examples is we also enabled the automatic import of CAPI clusters into the Rancher dashboard or Rancher UI. The other goal was it's upstream focused, basically limited Rancher specific code as much as we
we're trying to
and
adapter layer essentially.
And it follows the upstream versioning semantics. We have proper, we think, release guidelines and versioning and release cadence. And we have the feature additions, different new features coming slowly, and
they will be there. Yeah. And we're gonna show in the demo the functionality it brings in full spectrum, as well as installation.
Yeah, installation. We have two options currently supported. The first one is via Rancher dashboard, and that's the recommended way to install the extension. The next one is via Helm install. That's more for developer purposes. And there are two ways with Helm, so you can install turtles with cluster API operator as a Helm dependency or without cluster API as a Helm dependency. Cluster API operator is also upstream project that leverages the Kubernetes style APIs and makes it easy to use cluster API providers and enables the GitOps workflows.
Exactly. In comparison to what Cluster API initially supplied us with, it was a cluster.ctl, which is a CLI tool allowing you to bootstrap the template, sorry for the tautology, but it means like prepare all the specific environment definitions like IP ranges for the nodes or things like that in your local machine and then apply this in the cluster. This is not sufficient for the requirements we have. We want to support GitOps specific scenarios, and cluster API operator is fully compatible with GitOps, but it uses clusterctl under the hood as a library, so it all follows upstream practices, and we'll see how it works pretty well soon. Yeah, we have also some installation example from the Rancher UI, which we're gonna talk more and show the updated version of this in the live demo. It was like initial release for us, but still you can see it's very simple to do. You just need to bring a URL of our Turtles repository Helm chart, and then it automatically appears in the application set of things, and you can install it, and the operator will be running. It by default brings the cluster API core provider, RK2 bootstrap provider, control plane provider with it, so you don't need to worry about those things, but you can selectively, I'm gonna show this during the demo, install some additional providers like Docker or kubeadm if you want to try this out. Also AWS is fully supported. So those things can be done with Turtles once it's installed. Or as well, on top of this, we have an experimental UI feature which we're gonna show in the demo, which does those things from UI, as you can see, similar to what we have here.
Yeah, and don't pay attention to the versioning because it's a bit older version.
Yeah. We have Helm install commands as well as you want to try. Yeah, it's slightly outdated, but nevertheless, the documentation page you saw the link to has the up-to-date commands always. It still requires Rancher as a dependency, obviously, for Turtles installation, but it could be used for your testing purposes. So, okay. Now, short overview of what we're gonna show in the demo, and also what is CAPI provider. So this is the abstraction layer on top of clusterctl providers and the providers in CAPI world. When you create this resource, which looks like this, you essentially declare the desired provider installation in your cluster, and it will bring the controllers, operators attached to this and install in your cluster. Like in this scenario, it's a Docker infrastructure provider. It can declare some secret sources to store the required definitions for the provider to act themselves. As I mentioned before, the clusterctl tool in Cluster API is a CLI tool expected to be running from your local machine environment, while this is supposed to be fully isolated from the environment and run from the cluster. So we have to bring some of the secret definitions in this. As well as, although it's an experimental feature in Turtles world, we synchronize Rancher credentials to this config secret reference, so you can use your existing credentials in some environments to, well, try out, let's say, AWS provisioning with Turtles and CAPI without having to prepare all the components. Yeah, we have some variables. Like those are typically feature flags. As you can notice, we have cluster topology enabled by default. Cluster topology is one thing responsible for allowing Cluster API to work with cluster classes. Cluster class is typically just a template definition to reference from a cluster with most of the infrastructure components already aligned. It has some very powerful features like variable substitution, in-place patches, so you can adapt this to your use case, but you don't have to replicate this boilerplate declaration code to for your infrastructure. Yeah, and without this feature flag, it doesn't work. Cluster resource set, one of the things which required to provision, for example, CNI in your freshly provisioned cluster. This we're gonna also show in the demo how it will be deployed. And machine pools, if you want to try this experimental feature in upstream, also is possible. So, yeah.
Yeah. Next, we start with provisioning a cluster, basic cluster, apply the manifest, and yeah, we can observe the rollout, explore the dashboard extension UI. Next.
Yeah, we're gonna check our display how works label propagation from CAPI clusters, which comes handy with fleet integration, because we need to label our clusters the same way as you declared in the CAPI semantics, and so the application can be automatically deployed on those clusters. And we're gonna deploy a Nginx application using fleet as an example during the demo. Hopefully it will work to showcase that you can bring those things in your set of clusters without worrying much how it happens. So it's a sort of a simplification.
Yeah, and we have some operations on the cluster that will perform like by just editing the manifest, upgrading the Kubernetes version, scaling up the control plane, and see how the CAPI and overall Turtles extension performs the upgrades and scale.
Yeah, it will work in tandem with Fleet, so it will be fully GitOps compatible, and it's a typical operation you would expect a customer to perform, like upgrading the version or scaling up and down workers control planes. In this case, we're gonna scale control planes, which uses RKE to bootstrap and control plane providers under the hood. So that's more or less it. Let's jump to the demo. Here I have some prepared environment for the demo. What we did before, we just deployed our Rancher cluster, which is currently accessible. And if we go to this Rancher cluster dashboard, as you can see, it's a freshly provisioned Rancher without anything in it. There's a local cluster, there are some tabs, but everything is functional. We don't have Turtles installed, though. So that's what we're gonna do. We're gonna start with our things.
Sorry, before that, is it can you see it from the behind? Should we? Let me increase the
slightly increase maybe. Yeah. So hopefully it looks okay. Okay, so we'll need to install Fleet and use Fleet. So for this scenario, we're gonna bring our essentially Git source, which will act as a Git source, Git in our case, and we're gonna install this and start Fleet to work with it. So while it's preparing itself, the next step for us will be go to Rancher UI and install Turtles extension and UI for this extension, a separate set of components, which is pretty easy to do. Extension for UI is currently experimental, so there might be issues with it, but so far it was working well, so hopefully everything will be okay during the live demo. So I'm not gonna open the domain. As you can see, it says the local installation. But yeah, so now that Git is ready, let's go to our local cluster and go to our applications repositories. I'm gonna create one. I'm gonna bring some of my notes from this.
So basically here we'll be following pretty much same that we were showing previously. Installing the Turtles via the Rancher dashboard.
Yes, exactly. So it's a Helm chart source. We're gonna create one. Nothing else is needed. It's active. It's good. The next step for us will be to bring our UI extension, which is also another link. They so far using Git source. So Turtles UI and the Git repository with GitHub pages.
Branch.
Yeah, branch. And once it will be active and okay, we should be good to go into our charts UI. And you might notice that in comparison to the default set of available components, there is a Turtles. So that's our UI installation procedure. As you can see, there's a 0.8 version latest. That's the one we released. You're gonna click install and do some additional steps. Like we want to customize Helm options before installation, so we can also view those settings, but we also can edit all those things. What you see right now in this set is a default options. If you don't check or don't change anything, that's how the operator is gonna be installed. webhook settings if you want to override the default kubectl version or use your own. But one of the interesting things is our features, which we are currently developing and available, although as experimental ones. We can label Rancher kubeconfigs, which is enabled by default. I'm also gonna enable this fleet integration with CAPI, which should allow us to show the app deployment later on. And also propagation of CAPI labels, which is somewhat corresponding with fleet integration. So we're gonna essentially it brings the same thing, but using fleet add-on provider, which we'll install later. And we can also use management with tree cluster, which is a new development from architectural point of view. It's an improvement over what we are using. That's required for turtles to import the cluster automatically to the Rancher UI, which we'll see in next steps. So let's not talk that long and install our turtles extension. It should be installed soon. In the meantime, we can go to extensions and enable our UI extension configuration. Yeah, it takes some time to install because in the meantime that Rancher Turtles is installed, we are also updating some of the webhook configuration for Rancher, so it may take a short while to load, but hopefully it will finish up soon. Oh yeah, very good. So let's wait for this to load. Okay, so we're gonna enable our extension support. Let's go back to our full screen. Once this enables itself, we'll see the similar dashboard as in applications for Helm charts, but for UI extension. We're gonna click one and yeah, let's see available ones. There is a CAPI UI. We click install. And while it happens, so apparently it did install itself. Let's reload the page, close the engineering menu accidentally. And with that, we now see some improvements. We're gonna show it to you, but the first thing we can go to local cluster. And the most important part of this, to enable automatic import of your CAPI clusters, you want to go to your set of namespaces on the local cluster and click the Enable Cluster API Auto Import. With that thing enabled, now everything which is created in the default namespace, any CAPI cluster will be automatically imported in your Rancher UI. And we have the cluster management, which now contains the new tab, which is related to the cluster API. This is our UI extension work. As you can see, we have no clusters so far, but we have some providers already. So the core one, RK2 Bootstrap Control Plane, and Fleet. All of them are ready, but nothing else is there. We can also create one for Docker, for example. Let's create one and see how it's provisioning. So once it's provisioned and it picked the same version as the core installation, which is currently 1.4.6, it should be available and ready. But to check this out and also see it, I'm gonna pull up the cluster, connect to this, and use K9s. Oh. Okay, demo. So if we pull our K9s, as you can see, there's something. There are some pods. There's Fleet Controller Rancher, and also there's a CAPD Controller Manager, which was just present with our Docker provider installation. And we have also Cluster API Provider Fleet, Cluster API Operator, which we talked, and we're gonna show we already saw essentially the functionality it provides, the installation of these providers. How it's happening on the background, we have the CAPI Provider custom resource, which you can see similar to your UI dashboard, which contains all of those providers installed together. So what we want to do next? Now that we have Git installed, we want to install our providers. So we want to first establish our Git source, which is Git in this case, and make providers, and move our Kubadm Bootstrap and Kubadm control plane providers to this Git repo. And yeah.
So by default, RK2 kubeadm and Bootstrap providers were installed. So now we are installing the
Using Fleet.
kubeadm.
Yeah. So doesn't matter. So we should also see some things appearing from that dashboard as well. So you can see so far, yeah, two new providers just appeared. They are provisioning. That's the Fleet working on the background using the local cluster as a target. Fleet by itself will also target our child clusters. We're gonna use the cluster groups, and one of the features we provide if you use cluster classes, the Fleet add-on provider automatically create cluster groups. What is cluster group though? It's like there are already some names like cluster in Fleet and cluster in CAPI. They're different resources, but they act together. One of them is a destination declaration for where those Git repositories should deploy their manifest, either Helm charts or any sort of Git source, or just a set of manifests inside the bundle. And the cluster group is a set of those clusters labeled somehow specifically, so it automatically provisions the same thing on each and every matching cluster. So Kubadm Bootstrap and control plane are ready, so we can go ahead and add our cluster using GitOps. So we're gonna use cluster class, and we're gonna create our cluster. I can probably show the cluster from UI, and also we're gonna bring our cluster resource set containing the CNI definition, which is KNet for Docker cluster as well. CAPI will be responsible for deploying those things on the freshly provisioned cluster, so the network setup inside the cluster behaves as expected. Now, yeah, it should reconcile itself slowly. We can observe how it happens. We can go to our cluster management, clusters, and hopefully in a couple of seconds, once the Fleet reconciles this, it already created the cluster for us. It's visible from UI, waiting for infra provisioning, so scaling control plane nodes. We can also view the cluster, I believe, and that's how it looks like. It's a very simple one. You might notice the reference to Kubadm control plane, Docker cluster under the hood, and also very important one, topology class, quick start, which we used for the rest of the templated infrastructure definition, which is inside the cluster classes. The cluster class in question is this one, which you can also view, I believe, from the UI. You can also edit the YAML, though. Yeah, so you can see some JSON patches. It's pretty complicated, but this means that you can bring some of the variable definitions to override existing template how much you want. It's a pretty complex feature. I'm not gonna show all the details, but yeah, it works. You can use it with Rancher and Cluster API. In the meantime, you might notice there's a new cluster 1 CAPI in the dashboard. That's the default Rancher dashboard. And currently, this cluster is provisioning. It's already pending. Once the control plane stands up and Turtles deploys the agent on this cluster, it will connect back in full and will be fully capable to explore itself from the UI. So you can see the metrics, see the resources there, and work with this similar as to local cluster we have right now. Let me quickly jump to our KNS, so we can also view the machines, so it doesn't matter from where you look at those things. Those are running, so it's good. Hopefully this pending will move to something more than pending soon. We can also see the cluster from the kind and connect to this cluster 1. Okay, yeah. So Now we connected to this new cluster. Let's see some pods. As we can see, this cluster cattle agent is currently being created. Once this finishes rollout, it should appear in UI normally. That's one thing which is pending. It might take some time though. Yeah, it's waiting for the API to be available. So that's what's happening under the hood. Hopefully it finishes, but without this, we can jump to our fleet integration, which is, go back to our demo cluster, and we have next step, is gonna be deploying application with GitOps. So let's deploy our dev cluster group. It's possible to use your own cluster group for some scenarios when you want some specific selection logic, but it's not required. Right now, if we'll see our cluster groups in the origin Rancher cluster, there's already one for cluster class created. And the Nginx bundle, which we are going to create now, also targets both cluster groups, so overlap there is. But yeah, from the safe side, it can be used either way. So cluster groups, there are two of them. It's already reconciled Nginx bundle, so you can see that Fleet created the Nginx bundle in the local cluster, as well as it already reconciled the destination clusters. And as you can see, everything is ready. So both of them are targeting different things. If we view this cluster group quick start, you can see that it matches some specific label, which our Fleet add-on provider creates for us. So with that, we can go back to our cluster one, and we can see the Nginx appearing here. It has no logs, I believe, but it was just created, so Fleet did it for us. And I think that at this point in time, yeah, our CAPI cluster is also fully ready. So we can go to UI and see, for example, nodes. We have 2 nodes so far, which we're gonna change in the next step. We're gonna scale up our control plane to 3 members. And if you notice that right now the cluster somewhere, I believe, has to have declared that it uses version 127. Yeah, so 127. The next step gonna be we want to scale up our cluster and upgrade the version of Kubernetes cluster. So let's do this. And it's the last step. So we're gonna basically apply patch templates on top of this cluster and push. So it's pushed, and soon enough we'll observe that there are some changes happening in the clusters, in the CAPI cluster as well. As you can see, it's already rolling out some new replicas. Yeah, so how we can view this from UI, I don't believe we really can so far. But yeah, it takes some time to reconcile itself. Though we can see possibly some changes happening here. If we go to our clusters and connect back to this cluster one, we can see that Nginx application is still up, nothing is broken. There are no new nodes so far, it's still using 127.3. So let's check our demo cluster for the definitions. If it did change something, so we have a cluster, which is a CAPI cluster. But you can see here it's already 128.0. So we declaratively said that it's already going to the new version. It just didn't finish the procedure yet. And we might notice there are some new machines provisioning. So as you can see, it's 128 coming up. So soon enough it will appear in UI because the machine is standing up and it will replace the existing control plane instance. Yeah, I'm going to create several ones. It may take some time. You can see there's a new node coming up, still unavailable. But yeah, that's more or less all we have for the demo. You can jump back to slides and feel free to ask questions. I'm going to give word to Forkat.
Will this replace the current in use custom node drivers or node drivers from specific providers like vSphere, or does it act more like a separate add-on?
It's a separate add-on so far. So you can try out compatible, like you mentioned, with Sphere provider to install your cluster. But yeah, we are treating this as a thing on top and working on this so far.
For vSphere, it should come soon. We cannot give the dates, but we already tested and it was working. So
Yep.
should be available, but it's not yet in the list of supported providers
Will it replace Node drivers? Do you think?
as an add-on. Yeah.
Okay.
Well, it's a question about related to the vSphere provider and the API allocation. So we were testing the PAM provider in cluster that allows to define IP pools
Mhm.
for workers or for masters. And the question is that this is possible to use through the same way that you have import the extension to use cluster API through Rancher. The plugin is the PAM provider, for
Yeah.
example.
Yeah, it's possible. It's totally possible. We didn't though test this yet, but we don't have anything on top of what Cluster API provides. So if upstream implementation works for you, if you bring your testing environment, same thing will work with Rancher. You have expectations that will act the same. You although need to install this EPAM provider using CAPI provider resource, as you saw in the UI, but you can also bring upstream Cluster API operator provider types on its own if you want to test this out. But generally speaking, in our UI, it won't be displayed this way. So that's one of the things you might have in mind. But yeah, EPAM add-on providers, which was already one thing we wrote ourselves, this fleet add-on provider, is essentially something you don't have with Cluster API. You can install. It doesn't have to be there. It can be there. Anything possible.
Yeah. But if it works for CAPI, we don't test it. We don't have it in UI, but it should be supported through CAPI provider resource. If that answers your questions.
Hopefully. Okay.
Any other questions? We have some slides on roadmap and current status of the project. On roadmap, what we have is air-gapped environment support, data operations. Obviously, we'd like to support etcd backup and restore, in-place upgrades, thread rotation. Also, progressive cluster upgrades for fleet of clusters. And we are working with the UI team on UI enhancements. As you saw, it's still experimental, but it's growing and getting in a better shape. And also providers, basically additional providers that are supported by CAPI. We are planning to incrementally extend the list.
Yep. Once we test this out, have a
And
coverage
vSphere
and
is being
confidence
next.
in these things. Yeah. So how to contribute? We have some contribution guides. You can also go to upstream cluster API channel. We are there. It's different from Rancher. So